എല്ലാവർക്കും നമസ്കാരം. അസോസിയേഷൻ ഓഫ് എഞ്ചിനീയറിംഗ് പ്രൊഫഷണൽസും എനർജി കൺസർവേഷൻ സൊസൈറ്റിയും സെൻറ്റർ സിയും സംയുക്തമായി നടത്തുന്ന ഇന്നത്തെ വെബിനാറിലേക്ക് ഏവരെയും സ്നേഹത്തിൻ്റെ ഭാഷയിൽ സ്വാഗതം ചെയ്യുന്നു. ജനറേഷൻ, ട്രാൻസ്മിഷൻ, ഡിസ്ട്രിബ്യൂഷൻ മേഖലകളിൽ കൂടാതെ യൂട്ടിലൈസേഷൻ മേഖലയുമായി കൂടുതൽ വിവരങ്ങൾ പങ്കുവെക്കാൻ 20 വർഷത്തിൽ അധികം ഗവൺമെൻറ് ഓഫ് എഞ്ചിനീയറിംഗ് കോളേജ് ഓഫ് ബാട്ടൺ ഹില്ലിൽ ഇലക്ട്രിക്കൽ ആൻഡ് ഇലക്ട്രോണിക്സ് എഞ്ചിനീയറിംഗ് ഡിപ്പാർട്ട്മെൻറ്റിൽ അസോസിയേറ്റ് പ്രൊഫസറായി സേവനമനുഷ്ഠിച്ച, കൂടാതെ ഇൻഡസ്ട്രിയൽ മേഖലയിൽ KSEB, KTDC, സൈനോഷോർ ഇലക്ട്രിക് കമ്പനി എന്നീ മേഖലകളിൽ 5 വർഷത്തിലധികം സേവനമനുഷ്ഠിച്ച് പ്രവർത്തന പാരമ്പര്യമുള്ള റിട്ടയർഡ് അസോസിയേറ്റ് പ്രൊഫസർ ബീന മാം നമ്മോടൊപ്പം ഈ വെബിനാറിൽ ചേരുന്നു. മാമിനെ ഈ സെഷനിലേക്ക് സ്വാഗതം ചെയ്യുന്നു. ഒരിക്കൽ കൂടി ലൈവ് കണ്ടുകൊണ്ടിരിക്കുന്ന എല്ലാവരെയും സെഷനിലേക്ക് സ്വാഗതം ചെയ്യുന്നു. സെഷൻ ഹാൻഡിൽ ചെയ്യുന്നതിന് പ്രൊഫസർ ബീന മാമിനെ നിറഞ്ഞ സ്നേഹത്തോടെ സ്വാഗതം ചെയ്തുകൊള്ളുന്നു.
Thank you, Ajin, for this introduction. I'm going to present today this power system webinar. Usually power system എന്ന് പറയുമ്പോൾ what are the things behind this power system? We have generation, transmission, then distribution, and finally utilization. Okay. What is power system? A power system is a network of components designed to generate, transmit, distribute, and utilize electrical energy efficiently and reliably. That figure shows the entire system of power system, that is from generation, then transmission, then distribution, then comes to utilization. Main functions of power system. Generation, that converts electrical energy from natural sources, coal, hydro, solar, etc. into electricity. Transmission, transport high voltage electricity over long distance from power plants to substation. Then distribution delivers low voltage electricity from substations to homes, industries and business. Load means consumers, the devices, system or buildings that uses electricity. This is a block diagram of power system, generating station, then transmission system, distribution and utilization. Total generation in Kerala, that is we have 4412.14 megawatt is the total generation. This include both captive and KSEB's own generation. The right side we have seen the generating station, that is one of the highest, largest power station in Kerala. Generator transformer floor in Mulamattam power station. So you have seen that there are 6 generators in that Mulamattam power station, each having a capacity of 130 megawatt. You can see that the right side of this top view of the generator, we have transformers. The peculiarity of this station is this is indoor transformers, and each generator have 3 transformers. That means 3 single phase transformers are accommodated. Total 18 transformers are there, each having a capacity of 42.5 MVA. Then what is grid? Actually we have knowledge, many subjects we have heard about this grid. What is actually grid? A grid refers to the interconnected network that delivers electricity from producers like power plants to consumers like home and industries. We have power grid. We have a power grid means a power grid is a complex system made up of generating station, transmission lines, distribution lines and substation that work together to deliver electricity across wide area. This figure shows the that is power grid. We have actually 5 regions of power grid. That means eastern, western, northern and southern, northeastern. This is a 5 regions. Among this, the southern region, we have Kerala is in southern region, and southern region have other states like Tamil Nadu, Karnataka, Andhra Pradesh, Union Territory of Pondicherry and Andhra Pradesh. These states are included in southern region. So we have generating stations. starting from generating station. The different sections are there in each power plant. In Mulamattam, for example, the largest power station in Kerala, there are different departments like turbine section, water conductor, governor section, generator section, transformer section, exciter section, relay section, carrier communication section, and switchyard. So different floors are there: control room, generator floor, and turbine floor. The last one is switchyard. Okay. First, we discuss about the turbines. So this Mulamattam powerhouse is the largest power station I have mentioned earlier. Why it is underground? This is an underground power station. Why it is called underground? Because all the turbines are placed underground. That is why this station is called underground power station. Here we have used this Pelton wheel is a turbine, that is a impulse turbine. There are other turbines also, reaction turbine. Other power stations uses reaction turbines. Here we can use this impulse turbine. And the water conductor section play an important role, that inside this valve you have a actually like a butterfly valve. Why it is called butterfly? Butterfly means it is in the closed position. This is in parallel. This is in closed position like this, and in parallel when it is open means that is butterflies are in parallel like this. That is why it is called a butterfly valve. Okay. Then governor section. Governor section is an important section in all the power station, because all the control devices, that is control device used to regulate the speed. For example, we have in Mulamattam generating station, the speed of this turbine, the generator is 375 RPM. Whether it generates 30 megawatt or 40 megawatt or it is 130 megawatt, the speed remains constant, that is 375 RPM. That can be achieved with the help of this governor. So control device used to regulate the speed, maintain constant speed of the generator by controlling the mechanical input. Then important for frequency stability. That means you have studied about the speed drop characteristics. So this important for frequency stability. So frequency remains 49.5 to 50.25 etc. Adjust mechanical power input to mechanical electrical to match electrical load changes. Whatever the load changes, we can adjust the governor with the help of some pressurized signals elements. So this can be achieved with the jets are controlled by this pressure valves, or whatever be the suppose 30 megawatt or 130 megawatt, whether all the jets are in fully working condition, all are determined with the help of this governor. The main parts, the generator part, the main parts you have already know. This rotor and stator. In Mulamattam we have used salient pole alternator. This is which converts mechanical energy into electrical energy. A shaft connects the turbine to the rotor. So I have already mentioned it is a Pelton wheel. That Pelton wheel you have connect your generator like this. That's a vertical turbine. Cooling system uses air, hydrogen or water to remove heat from the generator. So bearings, that is also an important thing in generating station. So cooling system uses air, hydrogen or water to remove heat from the generator. Voltage regulator controls the output voltage by adjusting the field current. So bearings support the rotor and allow smooth rotation. Then exciter section. So exciter means that provides DC supply to the rotor windings of AC generator. So whenever there is a power station, we have used sometimes electronic excitation or mechanical excitation. Here we can use DC supply by thyristors. This DC current creates magnetic field necessary for the generator to produce electricity. It is necessary as the rotor needs a magnetic field to induce voltage in the stator. Example, static exciter. That means it uses thyristors, SCRs. Then relay section, that is also an important section in power station. Relay section refers to the protective relays and circuitry used to protect the generators from damage. They detect abnormal conditions and trigger the circuit breaker to protect the generator and related systems. Different types of relays are overcurrent relays, earth fault distance relays, and differential relays are used in the stations. Mainly in substation, we have used only two, mainly overcurrent and earth fault relays. Carrier communication, that is another important section. Carrier communication in power system refers to using high frequency signals transmitted over power lines to carry data or control signals between substation or between a substation and a control center. Because all the operations are carried out relayed by using this carrier communication. So, a wave trap prevents high frequency signals from going into the unwanted line directions. Switchyard, because in a switchyard, the generated power is collected, controlled, and transferred to the transmission system. It is like a power traffic controller. It ensures electricity flows safely and efficiently from the generator to the grid. It connects generator to transmission lines. Figure shows the example of a switchyard. In switchyard, there are some protective equipments like circuit breakers, isolators and relays, CTs and PTs, control panels, lightning arresters and bus bars. The wave trap stops high frequency signals from entering unwanted paths. Then we comes to the transmission section. Then transmission network is the backbone of any power system and enables transfer of bulk power from the generating station to the load centers. Figure shows the schematic diagram of this transmission, how transmission takes place. Transmission SBU manages the construction. That means strategic business unit, operation and maintenance of EHT substations and transmission lines, including that to EHT consumers, extra high tension consumers. It is also responsible for the implementation of transmission loss reduction programs and coordinating the activities for system development. Figures shows this how this transmission carried out, generation and then step up transformer. We have used in generating stations, we have used step up transformers, then 11 kV to 130 or 132 or 230 or 110 kV voltage. Then we have primary transmission and then we have used a step down transformer. Then we have a receiving station, secondary transmission. There also we have used step down transformers. Then we have substation. For example, if we have so many substations like 110 kV, 220 kV or 66 kV, what is the meaning of that? If 220 kV means that the incoming line coming to that station is 220 kV. That is coming from some other generating station or some other substations. Okay. So we have primary distribution. This is about this transmission. Then transmission components, voltage levels typically 132, 220 kV, 400 kV and higher. Two main parts, primary transmission and secondary transmission. Advantage of high voltage transmission. Why we transmit this voltage in high voltage? Because it reduces current for same power, then reduces loss due to high resistance, I squared R losses, allows smaller conductor size and economical for long distance. That is basic law of resistances. Law of resistance. Length increases, resistance increases. Then area of cross section is inversely proportional. Okay, R is inversely proportional to area of cross section. Then in an electrical transmission system, power transmission lines, several physical and electrical effects occur during the transfer of power from generation to distribution. So what are the effects? Skin effect, I already studied proximity effect, Corona effect and Ferranti effect. What is skin effect? That is, current tend to concentrate near the surface of a conductor, reducing the effective cross-sectional area of the for conduction. That is caused due to self-induced magnetic fields causing higher inductive reactance inside the conductor. Increases the effective resistance, that is higher losses, more prominent at higher frequencies and in thick conductors. Proximity effect, the distribution of current in a conductor changes due to magnetic field, that is also inductive effect, magnetic fields from nearby conductors. So increases resistance and losses, cables where conductors are close together. Then we have Corona effect, this ionization of surrounding air when the electric field at the conductor surface exceeds the breakdown strength of air, 30 kV per centimeter. Then power loss, audible noise, radio interference, ozone formation are the causes. Then can be mitigated by using bundled conductors, increasing conductor diameter, etc. Then Ferranti effect, receiving end voltage become higher than the sending end voltage when a long transmission is lightly loaded or open circuited. Caused due to line capacitance, charging current and line inductance causing voltage rise. Can be mitigated by using shunt reactors or absorb reactive power. Components of a transmission system. Transmission network has three major parts: transmission lines, substations and control and communication. Transmission lines carry electricity. Substation transform and control power. Control and communication means monitor, protect and manage power flow. Transmission lines and structures. Conductors, we have seen this right side, the conductors, wires carrying current, ACSR. What is ACSR? Aluminium conductor, steel reinforced. Then high temperature low sag conductors or bundled conductors. And towers, steel supports for safe clearances. Earth wire, OPGF, protects optical ground wire. Protects from lightning plus carries optical fiber. Then insulators, isolate conductors from towers, suspension or tension type. Then underground cable, XLPE, used in urban or critical areas. XLPE cable is used in Moolamatam also, cross-linked polyethylene. Substation overview, critical nodes for transforming, switching and monitoring power. What are the key components of substation? We have transformers, switchgear, bus bars, instrument transformers, surge arresters, gas insulated switchgear, reactive power devices, earthing system. Transformers, these are power transformers actually. Key role, change voltage level for efficient transmission and distribution. Then power transformers are used in transmission. Distribution transformers serve local areas. Equipped with protection devices. Buchholz relay that detects gas accumulation internal faults. This is the only relay which is used in transformers above 500 kV. Then Buchholz relay, sudden pressure relay, detects rapid pressure rise inside the tank. Then example, Etumanu substation uses 220 bar 110 kV transformers. Switch gear, essential for control, protection and isolation in the power system. Then circuit breakers, CBs, VCBs, GIS. VCB vacuum circuit breaker or gas insulated. interrupt high current during faults. Then disconnectors or isolators provide safe visual isolation for maintenance. Earth switches ground equipment safely. High speed earth switches operate under fault condition. Then bus bars, we have first of all we have no idea about what is bus bar. Different sections we have mentioned about bus bar. In panel board also we have bus bars. In substation we have bus bars. So what is actually bus bars? Are conductors that interconnect equipment inside a substation. That is mentioned about the large size bus bars. Okay, we have seen in the right side the bus bar figure act as a central node for incoming and outgoing feeders. Arrangement: single bus bar, simple but less reliable, and double bus bar, higher reliability and flexibility. 1.5 breaker scheme, high reliability, often used in EHV substation. A 2 substation also have this 220 kV and 120 kV bus bars. Instrument transformers. We have different transformers. This is one of the important transformer used in substation and generating station, used for measurement and protection. Because we have not used any ammeter for measuring this high current, so we have used this instrument transformers for measuring high current and high voltage. Then high current transformers reduce high line current to standard values. Example, 5 ampere, 1 ampere for relays and meters. Then voltage transformers, VTs and PTs, step down high voltage to standard levels. Example, 110 voltage. Capacitive voltage transformers, CVTs, used in extra high voltage system for protection and communication, that is carrier coupling. Other substation equipment, surge arresters, or otherwise we call it as lightning arresters, divert lightning and switching surges to ground protecting equipment. Then gas insulated switchgear, compact SF6 filled system, used where space is limited. Reactive power devices, they are shunt capacitors, STATCOMs, that is static. Shunt capacitors supply reactive power, improve voltage profile. STATCOM or SVC, dynamic reactive power control for stability. Earthing system prevents electric shock, protects equipment and ensures safe fault clearances. This is the lightning arrestor and gas insulated switch gear. Control, protection and communication. Protective relays detect abnormal or fault condition, whether it is overcurrent, earth fault, distance differential, REF, restricted earth fault. These are the protective relays used in substations. SCADA, that is a modern technique to identify this system. Supervisory control and data acquisition, monitors and control substation remotely. RTU, remote terminal unit, gathers data from field devices and sends to control centers. Substation automation uses IEDs, intelligent electronic devices, and bay control unit for smart monitoring and control. SCADA system uses in Moonamattam also, because we have a load dispatch center in Kalamasheri, which is located in Kalamasheri, and the operator in the load dispatch center, without any communication, he can understand how much is the generation in Moonamattam or each generating station, and if it is not increased, they can call the operator in the Moonamattam power station and say that there is extra megawatt available in third or fourth generator to increase the load. But the operators who are handling in the control room in Moonamattam power station is not able to increase all the machines together and fully 780 megawatt, because it is a risk factor. If it is increased more 780, that is a risk factor in peak time. Okay, so that SCADA himself can understand what much is the power left in that station, etc., can be identified. A remote terminal unit also gathers this data from field devices and sends to control centers. Communication system. Transmission system requires robust communication for data, voice and protection. Technologies use PLCC, power plant carrier communication, microwave or radio communication, optical fiber communication, then VSAT satellite. Modern grids use MPLS, multi-protocol label switching, for reliable packet-based communication. Then advanced monitoring phase WAMS, wide area measurement system, provides real-time wide area grid visibility. PMUs measure voltage current phases with GPS, time stamping for stability monitoring. DC supply or station batteries, that is an important thing. That is heart of the station is DC supply. Then provide uninterrupted backup power to relays, breakers and communication system. Anti-pumping devices prevents repeated breaker operations when both open and close commands exist. Reclosing. This is anti-pumping device. This is a phaser measurement unit. This is an overview of distribution system. So that's the end of the transmission, and then we pass on to the distribution. So consumers are depending on this distribution. There we have used this distribution transformer instead of power transformers. The distribution system delivers electricity from substation to consumers and is the revenue center or cash register of the power sector. So figure shows the outline of how we can reach electricity in our houses. 11 kV, 3-phase delta star distribution. That is an important factor. It's always a delta star because the input primary side is a delta connection and the secondary is star connected always, because we have 3 phases and a neutral. If you want a single phase supply, you have 1 phase and neutral connection. If you want 3-phase connection, you can also take 3-phase connection from the star. If it is delta, it is not easy to take the single phase supply. That is why this delta star connection is recommended for distribution transformers. So this is the way in which you have taken phase R phase, B phase, Y phase and R phase, and you have neutral. The voltage between, that is phase voltage and line voltage is there. Phase voltage is the voltage between any one of the phase and neutral. Line voltage is voltage between any 2 phases. Okay. If you have house 1, house 2, house 3, and house 1 is a single phase consumer, and house 2 is also a single phase, but factory 3-phase load. That's why that 3 phases are shown in this figure. Okay, voltage step down from transmission to consumer level, reliable power delivery to households, industries and commercial users, system protection and metering for safety and revenue assurances, act as the last and most critical stage in the electricity supply chain. Lines and supporting structures in distribution. We have LT lines like this, and high tension lines operate at 11 kV, 22 kV or 33 kV, carry power from substation to distribution points. Common conductors ACSR, aluminum conductor, steel reinforced, raccoon for 11 by 33 kV lines. And low tension LT lines, that is supply at 230 volt single phase and 400 or 415 volt 3-phase, deliver power directly to consumers. Then ACSR type, squirrel, weasel, rabbit. Then service lines, the final link between the main consumer's premises, single or 3-phase. These are the high tension lines and this is the LT lines. Stop. ABC, that is aerial bunched cables. These cables are used, insulated, theft proof, reliable for congested areas. That is underground cables. How these cables are laying, etc. can be seen. Underground cables avoid right of way issues, ensure uninterrupted and aesthetic supply. Then poles and structures, PSC steel poles, cross arms, brackets, stay wires. This provides strong physical support to overhead networks. That is ABC, aerial bunched cable. This is a transformer and production in distribution. We have give least importance to the distribution side, and very much important is given to this two-pole structure. This is a two-pole structure, power transformer. Here is a this is a distribution transformer. Then power transformer having 33 bar 11 kV, step down from HV to 33. Diagram all are having first lightning arrestor, then AB switch and DO fuse. But practically, whenever we install this two-pole structure, and can see that AB switch is at the top, because whenever we can open, a maintenance is there, we can easily open this AB air brake switch, open this switch and do your work, and you can earth these poles. Okay, that is why, that's a reason why AB switch is kept in the first position, top position. Metering and associated equipments. These are energy meters from electromechanical or static meters with LCD displays. Record kWh, kVAh, kVARH demand values. Then smart and net meters, that is a two-way communication, remote monitoring, import or export renewable integration, detect tampering and allow real-time data. Capacitors improve power factor, reduce reactive power burden, stabilize voltage. Then earthing system, pipe, coil and pole earthing for safety. Transformers and generators, neutrals grounded with multiple connections. So that is a very important thing for earthing. Control panels and TTBs, house relays, ammeters, voltmeters allow testing meter replacement without supply interruption. Danger notice, safety signboards with a skull and bones on equipment above 250 voltage. Then utilization of power. That is about the distribution. Then comes to utilization. How we can utilize this power? Then electricity is delivered from the distribution transformer, usually 415 voltage, 3 phase or 230 volt single phase, passes through the service mains, then energy meter, then main switch and then to distribution board. So we have some protective devices also, MCBs, miniature circuit breakers, RCCB, residual current circuit breaker, sometimes RCBOs are also used. Then ensure safety from fault and leakage current. This is energy meter, this is a miniature circuit breaker. Whenever there is a fault occur, this automatically trip and we can ensure that there is some fault existing in the wiring system. Types of utilization. Domestic utilization. Then power is generally power is used in generate low to medium scale, ranging from few watts to few kilowatts per device. Example, lighting loads, CFLs, LEDs, lamps, heating loads, heaters, geysers, coolers and refrigerators, electronics, mobile chargers, laptops, TVs, etc. This is a domestic utilization. Then industrial utilization, we have industries often receive three-phase supply directly used for motors, pumps, compressors, mechanical work, welding, furnaces, heating system, automation system, electronics, lighting requires stabilized power and sometimes dedicated substations. Commercial utilization, shopping malls, offices, hospitals and schools consume significant energy for lighting, HVAC system, computers, servers, lift, escalators, medical and lab equipments. So all these are types of utilizations are there. So we have come across this generation. First we have generation, then we have transmission, then we have distribution, finally we have utilization. So among these four devices, there are so many, in your point of view of examination, they have asked many questions related with this. So you have a overall view of about this, what is power system and how this is used and how this generators. The one more thing I have not mentioned earlier, what is synchronization? Synchronization is also related with the generation, right? So that synchronization, whenever you say synchronization, first you synchronize a machine to the bus bar, to the system or to the grid. How this machine is synchronized to the grid? We have such conditions, no? You can always remember same power, same voltage, same what is that? Same voltage, same frequency. How the same frequency is achieved? How the same voltage is achieved? How the same phase is achieved? All these things are achieved with the help of this components which is placed inside this generating station, right? So if you have frequencies monitored in the control room, suppose you have 48.5 frequency, in your machine have 48.5 frequency and your grid frequency is 50 hertz. And what is the meaning of that? Your frequency is less than the grid frequency, right? So what you have to do is, you have to increase the input flow of this fuel. That means you can adjust the flow of water by controlling the jet. So when you control the jet, you can adjust the frequency, because n is equal to 120 f by p, right? So when you adjust the speed, adjust the frequency, when jet control, you can adjust the speed. That is why you can adjust the frequency. So you can make it equal to that grid frequency. Grid frequency we cannot change. So we can change only the machine frequency. So that machine frequency can be changed by changing this input flow. Okay. Then voltage, suppose your grid voltage is 10.8 kV and your voltage of the machine is 11 kV. What you have to do? You have to increase the voltage. How can we increase the voltage? You adjust the field excitation. That is why voltage regulators are there for placing this, make it equal. The voltage should be make it equal and the frequency should be make it equal, and a phase sequence, that is always that can be done in your laboratory, can be found out by bright lamp method or dark lamp method, right? So in dark lamp method we can usually use this, and also a synchronoscope is placed there, and whenever this synchronoscope comes to this 12 o'clock position, this operator going to close that circuit breaker. And then that can be visualized with the help of some operators placed in switchyard. So that is why the machine is synchronized to the machine, synchronized to the grid. So this process is going on one by one when the peak is coming. That means peak time is from 6 to 10. So from 5:30 onwards or 5 o'clock onwards, the people in the power stations get ready for doing install this one by one. This is start by one by one. Okay. So there are some process behind this by starting this each machine. So turbine floor you have an operator, generator floor you have another operator, control room you have another operator as well as assistant engineer. So they have all put together. The switchyard there is another assistant operator. So all this coordination comes and finally we can close the circuit breaker by achieving all this data. That means frequency, voltage, phase, all these are equal. Then you close the switch. Then you increase the load on by the machine. Okay. So that is why the synchronization is done. So many process I have mentioned about the transformer in power station. So voltage transformers are placed, 18 transformers are there, I have mentioned. If there is a mistake or a fault condition occur in one of the transformer, what you have to do is you can break the wall and then take it out and put in another one. Extra is there, for extra one is already kept in this power station. You can put that transformer in that. cabin. That water force cooling system is used in that transformers, and that's a wonderful power station. I'm very lucky for working in 2 years in power station, underground power station. That's a great experience for me for teaching also. That is about this agricultural utilization. Utilization, electricity is supplied for irrigation pumps, tube wells, then threshers, crushers, and farm machinery, cold storage of produce. Then public utilities, power used for community and city functions, street lighting, railways traction and metro systems, water supply and sewage treatment plants, communication and IT infrastructure. All these things we have utilized our electrical energy. So whenever we comes to an end of this utilization, you have seen that industries and high-rise buildings require DG sets. Have you heard about that? The diesel generator set in each 11 kV high tension consumers, because nowadays we have no power cuts. So people have a misunderstanding what is power cut and load shedding. So load shedding is actually done from the substation, and power cut is actually exclusively for 11 kV consumers. So I have mentioned that DG set is provided in all 11 kV consumers. Whenever the government decided to provide a 20% power cut to industries or high tension consumers, means they can utilize only 80 units, and other 20 unit is taken from their generator. That's a meaning. That is a power cut. So power cut is only for 11 kV, that means HT consumers, and load shedding is for LT consumers. Okay. That's about this utilization. I think this is an overview of this power system. If you have any clarification, you can ask some questions. Okay. That's an open discussion. You can ask questions.
പവർ സിസ്റ്റം എന്ന ഇന്നത്തെ വെബിനാർ കണ്ടക്ട് ചെയ്യുന്നതിന് വേണ്ടി നമ്മുടെ ക്ഷണം സ്വീകരിച്ച് എത്തിച്ചേർന്ന പ്രൊഫസർ ബീന മാമിന്, അതേപോലെ തന്നെ സെഷനിൽ പങ്കെടുത്ത എല്ലാവർക്കും ഹൃദയത്തിൻ്റെ ഭാഷയിൽ നന്ദി രേഖപ്പെടുത്തുന്നു.